Good afternoon. Welcome to today's webinar on COMSOL Multiphysics CFD module. I'm Hakam Al-Asoy, Technical Support Engineer at Nadi Engineering and Agencies. We are the sole distributor of COMSOL Multiphysics in the Arab countries. Today we're going to have a brief introduction about the COMSOL Multiphysics CFD module, what kind of features you can find, what kind of tools you can use, and then we're going to have a simple model of a multi-phase oil and water buoyancy of a bubble buoyancy. For the CFD module, we have different types of flow. We can simulate laminar and turbulent flow, single phase flow, multi-phase flow, non-isothermal or conjugate heat transfer, non-isothermal flow and conjugate heat transfer. For the CFD module, also there is high Mach number flow, reacting flow with transport of dilute species and concentrated species with the chemical reaction engineering module, and thin film and porous media flow. Other than that, you can combine with other multiphysics or other interfaces using the rest of multiphysics capabilities we have in COMSOL. As for the laminar flow, we have Newtonian and non-Newtonian flow. For the turbulent flow, we have K epsilon, K omega, low Reynolds number, K epsilon turbulent model, and so on. And also, we have moving machinery or mixers module or rotating machinery you can use in the CFD module also. For the mixers, you can have a laminar and turbulent mixer, static mixer, or with the axial mixers. There's multiple ways you can create mixers or simulate rotating machinery in the CFD module, so you can check this out on the website comsol.com. For the multi-phase flow, you can use it to simulate dispersed phases, bubbles, for example, droplets also, settling of solids and liquids, separating solid liquids and gases by settling and dissociation of bubbles or coalescing of bubbles into a bigger bubble and separating the phase from, for example, clearing out oil in the oil field from like settling the sand and particles downwards and separating the gases into the vapor space in the settlers. You can also use it to simulate porous media flow for saturated and unsaturated porous media flow. Some of the examples you can have for multiphysics by combining CFD module with structure mechanics module. You can have a flow structure interaction as a one-way coupled or two-way coupled system, where the flow can affect the structure, and that structure can affect back the flow, such in the examples of one-way and two-way coupled systems in this slide. For the example today, we're going to have a simple multi-phase model of a water droplet arising due to buoyancy into an oil container. We can start by using COMSOL first. Let me switch to my other screen. In the beginning, we can start with the model wizard. The model is very simple, so it's going to be a 2D axisymmetric or two-dimensional axisymmetric model of a tube with a bubble rising in the center. So we can have it as a 2D axisymmetric and then rotate it during the solution to a 3D model. So 2D axisymmetric. Under the physics, I'm going to go to fluid flow, the multi-phase flow, and then select the two-phase flow level set, and then laminar flow in this case. This is the multiphysics combining the two-phase flow with the level set. So you can see now all the features are available and the multiphysics combining them will be set. Going to study, I'm going to select time dependent with phase initialization. This is a two-step study or a two-step solver where you have initialization phase, initialization solver first, and then the time dependent solver kicks in later. A step 1 and a step 2. We're going to see this later when you're solving the model. Starting with our geometry, we can go to geometry, change the units to millimeter, and then start drawing our geometry. We can start by our clicking geometry. Let's start with the rectangle first. Yes. So the rectangle dimensions are going to be 5 and 15 and 15, and then the polygon is going to be drawn on it later. So this is my rectangle. It's going to start with R at 0, Z at 10, and then two vertices. My next vertex is going to be R at 0.5 and Z at 10. So it's not 10, it's R at 0. Yeah, there is an issue here. 5, not 0.5. Yeah, something. This is the line we should have. Next, I'm going to do half the bubble, which is half a circle or semicircle. So I have my circle here. I just need to have it as 180 degrees. If I draw it as is, it's going to be at the bottom here. I would like to move it to the top. So the radius is 2 millimeters, and I need to rotate it and move it to the middle area here. So it's going to be moved upwards in the Z direction 4 millimeters and rotation of negative 90 degrees to make it look like this. So this is for the geometry. And next for the material, we can go to material, right click on it, open the library, and then search for water and transformer oil. So let's look for the transformer oil. So this should be our domain, transformer oil. And then we're going to add water. So remove this, built-in water. We'll not select a domain for water now. We will select it later, but we're not going to use it as a domain. We're going to just extract the material property from it into the physics. So we'll leave it as is now, unselected. Next, we're going to go to the physics level set and select the initial interface. We're going to select initial interface level set model. Select the initial interface under a boundary condition and select these boundaries for the interfaces of the bubble and the flow. Next, I'm going to make sure that I have another initial value for another different domain, because I have two domains now, oil and water. So another initial value, which is initial value 2. My initial value is supposed to be fluid 2, since my initial value 1 is fluid 1. And then select this domain, which is domain number 1. This will make it overridden in initial phase or initial value 1 for the other phase. I can go to the multiphysics again and then specify which phase is which. So under the two-phase flow level set, I can select fluid 1 to make it transformer oil, and then it's gonna grab the whole properties from it, and then fluid 2 to be water, and under surface tension, I'm going to include one from here. I'm going to select water and oil if I can find it. Liquid interface, so it's going to be as a reference olive oil and water at 20 degrees Celsius. I can go back to my level set model. And then in the initialization parameter, I'm going to make it as 0.2 meter per second. 0.2 meter per second. And under initial values, I'm going to select fluid 2, phase 2, which is fluid 2. And this is the one being selected right now. As for the laminar flow, I would like to include gravity, since buoyancy will be against gravity in this case. So under physics, I'm going to make sure that we have gravity, include gravity. And this will add another node or another feature here under the physics for gravity. I need also to set a reference for the pressure, so I need to add a point constraint. So under points, I can have a pressure point constraint at this far end. Next, under the multiphysics, I need to add a wetted wall, which is the exterior wall for this tube, this wall. So I'm going to select these two boundaries for the wetted wall. As for the mesh, I can use the mesh which is automatically created. So as you can see, this is a physics controlled mesh for the whole model. I can increase the resolution going to fine or finer. This will increase the number of domain elements I have. So I can start editing it now using free triangular, for example. So it's very fine element, as you can see. It's almost black if I look from the outside. If I zoom out, it's almost a black piece. If I zoom in, you can see the tiny elements everywhere. So this should be the optimal settings for now, as finer for the predefined size and free triangular optimized for fluid dynamics. Next, I can go to my study. As I said, it's a two-step study. I have phase initialization first, solving for the level set. This is my first step in the multiphysics, and then Step 2 should solve for the whole model, but I should take into consideration step 1 as my initial values from a phase initialization. So this is the study settings for this model. We have a question? Okay. Next, I can compute it, but I need to compute it step by step. So step 1 first, and then step 2. Make sure it solves. This model would take around 15 to 20 minutes on my computer. So I already computed it one time, or I solved it one time earlier. So if you look at the solutions here, I can share my screen now. So if I look at the other screen, you can see the pre-solved model. You can get the velocity profile with a time-dependent solver. So you can go to one slide after the other. You can see also the volume fraction of fluid, which can depict the rising bubble. If we go to the first slide, next slide, you can see the bubble rising every time I click next until it pops at the surface. Or I can create an animation out of the 3D model, which is this model, or the 3D plot. I can create an animation out of it by going to results, animation, which should net this video. It should get me this video at the end. If I click play, you can see the bubble going to the surface. I'm sure the colors are not ideal. In this case, we can change the colors if I want. So I can create a 2-dimensional or 3-dimensional animation out of it. So if I go to this one and create an animation from it, from volume fraction, this one, it has a 50 frame for this time-dependent solver. So we can have a video out of the bubble rising to the top and popping. So water is rising from beneath the liquid and then joining the other phase of water up on the top, which is the red phase or the red surface.